Now we're ready for the crossword. I have the clues opened up on another screen so I don't have to go back and forth. The one across carries amino acid to ribosome, that is tRNA. Two down, the building block of DNA and RNA, nucleotide. 7 across, glucose, fructose, galactose. Those are all disaccharides. Disaccharides. Maybe I don't know how to spell disaccharides. Let's try 5 down. 5 down, adenine and thymine. 3 words, complementary base pairs. Oh, duh, glucose is a monosaccharide. Complementary base pairs. Glucose is a monosaccharide. Three down, the type of interaction that would occur between serine and proline. That's either hydrophobic or hydrophilic. We would figure that out by looking up their structures. We would need to see the structure of the R group. And if the R groups were hydrocarbons, so the R groups contained only carbons and only hydrogens, then it would be hydrophobic. And if they had like an oxygen or sulfur or nitrogen, it would be hydrophilic. I can tell just by the number of letters that this is hydrophobic. 13 across for neutral amino acids, its value is about 7. That's the pi. For 11 across, more than 2 but less than 40 amino acids would be a peptide. 14 across, will undergo hydrolysis to produce amino acids which are used by the body to synthesize a protein. I think that is a protein. 14 down, starch, cellulose, and glycogen are all polysaccharides. "15 across, the type of interaction that would occur between two cysteine, that is a disulfide bond or bridge. 16 across, hydrogen bonding among adjacent strands of amino acids makes a beta pleated sheet. "18 across, ketose, aldose, monosaccharides, disaccharides, polysaccharides. Those are all carbohydrates. 12 down, a strand of nucleotides. Nucleic acid, possibly? Yes. 20 across, sucrose and lactose, that is a disaccharide. Four down, mRNA synthesis, transcription. 6 down, the type of interaction that would occur between glycine and valine. That must be, that would have to be hydrophobic. So the one over here, obviously they're the same size. I thought I could figure that one out just based on how many letters there were, but they have the same number of letters. Hydrophobic. 8 down, amino acid assembly. Translation. 10 across, the major component of ribosomes is rRNA. 9 down, millions of nucleotides is one of the characteristics of DNA. 21 across, this linkage is between the OH group of one nucleotide and the phosphate group of another. That's the phosphodiester. 19 down, D-fructose, a monosaccharide, is an example of this type. D-fructose is a ketose. And I wouldn't expect you to know that off the top of your head, but you would look it up and see it's a ketose. 21 down, chain of amino acids in a protein is known as this type of structure. The chain of amino acids is the primary structure. 27 across, instructions for protein synthesis. That is the mRNA. They carry the instructions. 22 down, this type of structure comes from hydrogen bonding between amino acids. Hydrogen bonding between amino acids is the secondary structure. 33 across, this type of structure is a compact shape of a peptide or protein caused by interactions between the R groups. That is tertiary. 28 down, this type of structure is used to represent a monosaccharide in either the alpha or beta anomer. Haworth. 29 across, two or more tertiary structures of a protein held together. That is quaternary. 31 across, a protein that makes things happen a million times faster would be an enzyme. 25 down, ACG, GGG, UCU, those are all codons. 26 across, hydrogen bonding between every 4 amino acids, that makes the alpha helix. 24 down, amino acid with a positive nitrogen and negative oxygen is a zwitterion. 34 across, a single strand of nucleotides is an RNA. 32 across, put these together to make a protein. Put amino acids together to make a protein. 30 down, D-glucose, a monosaccharide, is an aldose. 23 across, an enzyme's helper is a coenzyme or a cofactor. And 17 down, where tRNA brings amino acids, brings them to the ribosome.